Now this is the second question. Let's start by reading. The projectile fired at an angle theta above horizontal from a point 80 meters above the ground. If the vertical component of the initial velocity is 30 meters per second upwards, how long does the projectile take to land to the ground? So for this case, we can start with the rough sketching. This is the ground. Let's say this is the cliff or whatsoever. You do know that this might be the subsequent picture, and you have launched with a certain angle that you do not know, but this is roughly the picture. So the question asks you, you launch from here, how much time it takes to land here. So you are looking for time of flight. So I'll start off by my famous equation. Once again, ask yourself, what is your SY? If this is where you launch it and this is where you land, you are looking at the difference here. The difference in the vertical height here is equals to 80 meters because it's 80 meters. Alright, and also very important to know that it's landed below, that's why I put a negative in front. So that's my correct SY. And how about my UY? My UY is already mentioned. Vertical component of the initial velocity is 30, so it's 30 here. Don't need to try to resolve, no point of doing that. Okay, so 30 is a UY followed by T and half of a G. G is minus 9.8 T squared. Okay, so please, when you're solving this, rearrange the quadratic equation. You must arrange in quadratic equation. So when you arrange, this is what you have. I bring all the term here to the left hand side. And then you can solve by using your calculator. You will have two answers. Minus 2.0, 0.01, 2.01. And the answer acceptable is certainly this. Okay, this is the acceptable answer. Okay, minus 2.01 happened here, yeah, it's happened here. So it's not physical yet. So that's my answer. Okay, I want to draw your attention to this. If you using this, and then you highlight to me that at maximum height the Vy is 0, which is true, but Ui is 0. Okay, when you solve the time here, okay, and then you multiply by 2, this one is completely wrong. Okay, why is it wrong? Look at the diagram, it's not symmetrical. If it's not symmetrical, this formula automatically will fail. So don't try to use it when it's not symmetrical. Please bear that in mind. Okay, having said that, the first formula here, this is always the safest, provided you can give the correct SY. So that's the first answer, 8.13. As well as don't use this here for non-symmetrical case. Move on. How about the angle if the projectile travel 576 meters? Hence or otherwise, calculate the initial velocity. So it traveled 567, so this is what we understand as the SX. 567. UX is unknown, but you do know now the time of flight 8.13. So get my UX. My UX is 70.8 meters per second. And at the same time, I do know my UI because question mentioned that projected 30 meters per second upward. So what you can do next, find the U by combining them using Pythagoras theorem. Okay, I leave it to you to do it. It is about 76.9 meters per second. That's the final answer. How about the angle? Just use the inverse tangent of Uy over Ux. Alright, and again, try yourself is 23.0 degree. Now since Uy is a positive sign, you expect this to be above horizontal. So that would be the answer for the magnitude as well as the direction. Thank you.